Hello, myself Medha Chaudhary. Today, in this video, I'm going to talk about predicting diabetes using machine learning. So, in this video, we have gone through the research paper and after research, we find out that we would be using machine learning to predict type 2 diabetes and addresses imbalanced data sheets to ensure reliable prediction. So the data set we have followed is followed from FSCS, which is FASA Adult Cohort Study. So after using the data analytics techniques such as data mining, data cleaning, and data visualization, we have not used data visualization, but after data cleaning and mining, we have got the final dataset size as 7,408 records after cleaning and pre-processing. So challenges we have addressed is the class imbalance, which led to the bias prediction. As there was no class and the classes were distorted, so the predictions were not accurate. And the different risk factors for men and women, such as BMI and SGOT for males, and TG and BMR, which is body mass index for male, serum glutamate, oxalates acetate transfeminized for male, and for females, triglycerides and basal metabolic rate. These were the classification, and to classify this, we have to address that which classification would be appropriate for males and females. The approach we have used for that, we have explored some models such as random forest, MLP, gradient boosting, decision trees. So the evaluation matrix we have used. So for balances and precision, we have used F1 score for measures how well the model distinguishes between classes. We have used area under curve, and for both majority classes and are predicted well to ensure that we have used G-means. Also, we have used the data balancing techniques, that is SMOTE, synthetic minority oversampling technique, which generates synthetic sample from minority classes. And the focus on the difficulty to classify the sample, we have used Edison. Uses for oversampling combined with noise reduction, we have used SMOTE and data balancing technique. So what are the key learning from the paper and implement key learning from paper and how we have implemented models implemented. So the random forest model, MLP classifier model, gradient boosting model. So these three models which help to know for feature importance analysis, captures complex and non-linear patterns, optimizes prediction using sequential learning. So using this, we have implemented the data normalization. So, in data normalization, we have used min-max scaling to normalize feature values between 0 and 1. Other than that, we have also done data balancing by applying this mod to handle the imbalance in the data set. So at the end, what we learned from the paper. So without imbalancing models favor the majority class. So MLP models perform well when combined with SMOTE and adhesives. And personalized prediction, the risk factors vary between based on gender. And for balance metrics, we have used the AUC and G means, which reduces both false positives and false negatives. So the models that after implementation on our data set and the analytics, the following result is occurred. So we have used these three models, random forest, MLP classifier, and gradient boosting. So after the comparison, we have got the final output in which the MLP achieved the highest AUC score of 0.89, showing the strong discrimination ability. Random forest provided the most balanced result with robust feature importance, and the gradient boosting was effective, but that required more tuning to achieve comparable results. So at the end, the results which after the model performance and the key features are. So after applying the random forest, the best result we got is the highest AUC score. The MLP and gradient boosting, they were strong but slightly less accurate than the random forest. So the key features of the random forest was the glucose, BMI, age. So the at last the feature analysis reveals the top predictors with glucose levels high having the strongest influence followed by BMI and age. So at last to conclude the effectiveness of the data techniques. We have used this SMOTE and addition, which have improved the model performance by addressing class imbalance and by ensuring more accurate prediction. Also, we have used to balancing data, use balancing data techniques, which would help the models perform better on the minority class. So, the significance of this personalized prediction was the research highlighted the gender specific predictors such as BMI and SGOT for men and triglyceride and BMR for women. So this targeted and incorporating such features which can lead to more targeted and accurate diabetes prevention strategies. So talking about the performance of the different models, the MLP achieved the highest AUC, showing it excels in capturing non-linear patterns in complex datasets. So the random forest effectively identified key predictors and provided feature importance insight, making it suitable for interpretability. Gradient boosting worked well for sequential learning but required extensive tuning to optimize results. So, using the machine learning, what is the future scope? So, the future scope is future engineering using the auto encoders and principal component analysis to reduce dimensionality and enhance feature extraction. Also, this is cost sensitive learning. Incorporate classifier that penalize misclassifying minority classes to improve predictions further. Hybrid ensemble learning. Combine boosting and bagging techniques for better performance and robustness. And at last, the adaptive samplings, implementing and reinforcement learning to dynamically adjust the resampling strategy based on model performance during training. So now I will show you the code. So, so we have used Colab for the code implementation in which we have taken this diabetes.csv as the data set. So for the graph, we have used imported the panda module, and then we have to load the data set. We have used this command and use this diabetes and include the diabetes CSV file. So we have used the min max scalar feature to normalize the features. So we have split the data into training and testing sets, which is a 80-20 split. So this command is used to install imbalanced learn, and to import SMOTE, we have used this function from imlearn.oversampling import SMOTE, applying a SMOTE to the training data. So after running this code, we have included all the packages and that are successfully installed. From this, we have trained a random forest classifier and we have predicting on the test set. So for the classification report, we are printing the Y test and the Y spread RF test. For the AUC score, we are using the random forest. We are printing this using this statement. So after running the code, we are getting the output. So here we can see the random forest AUC is 0.7646, which is around here and here. So similarly, we have used the same code for the MLP classifier. So we have used this code for MLP classifier. We have imported the MLP classifier module and then we are printing the report by classification report like Y test and Y grid MLP. So here you can see the MLP AUC as 0.73434. So similarly, we are grading, we are similarly we are taking the graph by using the gradient booster classifier. So we have imported the gradient booster classifier and then we are printing the output. So this is the following output using gradient boosting. So finally, we are visualizing the following graphs and we have plotted the ROC curves. So the following is the ROC curve which we have plotted using the functions and in the code. So this curve is for the random forest. This curve is for the MLP and this curve is for the gradient boosting. So at last, we would get the feature importance from the random forest model. And then we will plot the importances. So we have used this code to plot a bar graph for the random forest, in which attributes are glucose, BMI, age, diabetes prediction, diabetes pedigree function, blood pressure, pregnancies, skin thickness, insulin. And we have got this bar graph. So using the machine learning, we have predicted the diabetes for both men and women. Thank you.